Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now remember, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Anyways, on to today's puzzle, which is called Pride Flag by, I don't know how to pronounce that, Pjoter Bleep? Or it's Peter or Joder Bleep. I'm not sure. If you want to let me know how you pronounce that, just let me know in the comments. Anyways, here are the rules. Normal Sudoku rules apply. Place the digits 1 to 9 once each in every row, column, and 3x3 box. The flagpole is a thermometer. Digits increase from the bulb end. So the digits must always increase from the bulb all the way to the tip. So the tip being the largest number on the thermometer, and the bulb being the smallest number on the thermometer, and everything else being at least one greater than the next digit on the thermometer. The red line is a Renban line. Okay, so instead of pink or magenta, it's red. Okay. Which it contains a set of consecutive digits in any order. And usually it's non-repeating digits. And I'm assuming that's the case here because that's normally the case in a Renban line. Sometimes there are exceptions, but they're very few and rare. So I'm assuming it contains the digits of consecutive digits without repeats. Okay. And so if you had a 1 on here, you would know that you would also have to have 2, 3, 4, 5, 6, 7, and 8, because that's the only consecutive set of non-repeating digits. And again, we'll figure out eventually if this has to be non-repeating or not. But 1 through 8 is the only set of 8 digits that contains 1, which is consecutive. And that's the reason why, if you have a 1, you know the rest of the digits are 2 through 8. And that's Renban line. The orange line is a Dutch whisper line. Adjacent digits on this line must have a difference of at least 4. So for example, if this were a 2, or not both of them, if one of them was a 2, this would have to be 6, 7, 8, or 9, because you have to have a difference of at least 4 between adjacent digits. And that's how Dutch whisper works. The yellow line is a 3 whisper. Adjacent digits on this line must have a difference of at least 3. So similarly to the Dutch whisper, instead of being 4 different at least between adjacent digits, it's 3 different. So for example, if this were a 2, this would have to be 5, 6, 7, 8, or 9. Or say if this were 5, it would have to be 1, 2, 8, or 9 to be next to it. And that's the 3 whisper. The green line is a German whisper line, which have adjacent digits on this line must have a difference of at least 5. So it's the same as a Dutch whisper or the 3 whisper line, but it's instead of being the difference being 4 or 3, it has to be 5. So for example, if this were a 3, this would have to be an 8 or a 9 to be adjacent to it. The blue line is a region sum line. Sections of this line within a 3x3 box have the same total. So that means the sum of these 3 cells must be the same as the sum of these 3 cells, which must be the same as the sum of these 2 cells. And that's how region sum lines work. And the purple line is a parity line. Adjacent digits on this line must have opposite parity, odd and even. Which means if this were a 1, the adjacent digits on this line would have to be a 2, 4, a 6, or an 8, because this is odd, and therefore it would have to be next to an even digit, and vice versa. Digits separated by an x sum to 10. So for example, if this were a 3, this would have to be a 7 to add up to 10. And digits separated by v sum to 5. So for example, if this were a 3, this would have to be a 2, because these 2 digits must add up to 5. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first then. This has to be 1, 2, 3, and 4 because it's either two digits adding up to 5 must be either 1, 4 or 2 and 3. Let's do the thermometer. This must be at least 9. This is at most 8. This is at most 7. This is at most 6. And this is what I like to do with thermometers. So this would be 5, 4, 3, and 2. Therefore, this could be either 1 or 2, which makes this 2 or 3, 3 or 4, 4 or 5, 5 or 6, 6 or 7, 7 or 8, and 8 and 9. But on a German whisper line, we know you cannot have a 5 in normal Sudoku on a German whisper line. Because 5 is 5 away only from 0 and below, and 0 is not a normal Sudoku digit, or it's 5 away from 10 and above. 10 and above not being digits. So therefore, this has to be a 4, which means this has to be 3, this is 2, and this is 1. Therefore, since this is 4, it can only be 5 away from a 9. So this has to be 9. And on a German whisper line, you'll always alternate between lows and highs, because 1 through 4 can only be next to 6 through 9, which can only be next to 1 through 4 again, and you always go back and forth each time. So therefore, this is low, this is high, this has to be low, this is high, this is low, and this is high. So this has to be 1, 2, or 3, but it can't be 3 or 4 because of these 3 and 4. So this is 1 or 2. This cannot be 2 and 3 because of the 2 here. So this is a 1-4 pair. This can't be 1 or 2. This is 7 or 8, so this is with 2 or 3 specifically. This has to be... This is on the German whisper line is next to 2 unique digits. So it cannot be 6. It could be 7, 8, or 9. This is also next to 2 unique digits on a German whisper line. So this cannot be 3, 4, and the 3 eliminates that from being a 3. So this is a 1, 2, 1, 2 pair. This digit has to be 3 away from 3. This has to be 4 away from 2. So this is 6, 7, or 8, but it cannot be 9. This can be 6, 7, or 8, because this could be 1 and this could be 1. So this is 1, 2, 3, or 4, which makes this 6, 7, 8, or 9. Do we assume that the Renban is a normal Renban? I think so, because it doesn't really make sense that it wouldn't be. So therefore, this would be 4. This would be 1. Which on a Dutch whisper line would mean this would have to be 5, 6, 7, 8, or 9. This can't be 2 again. Oh yeah, this can't be 1 anyways, right? Even if we tried it without that rule, if it went 1, and it has to be continuous in some order on a Renban, it would have to be like 1, 2, and then back down to 1, but then back up to 2. So it would require 2 2s on the Renban if you included a 1. So therefore, this cannot be 1 and 1 because this can't be 2. This can't be 2. We're only allowed 1, 2 here. And therefore, it can't be 1, 2, 1, 2. So therefore, either way, this has to be 4, which makes that a 1 then. The 2 has to be one of these 3. The 1 is one of these 3. We also know there's a 3 somewhere along this line, but we're not sure which. The purple line is a parity line. Okay, we don't know what that is then. So this has to be 5 through 9. The 6, 7, or 8 is 3 away from... The 8 can be 3 away from 1 through 5, but it can't be 1, 2 here. So this is 3, 4, 5. The 7 can be away from specifically 1, 2, 3, and 4. 1, 2, and 3. This can't be 5. So again, the 8 can be 4 away from 1 through 4. But 1 and 2 are already taken into account. The 7 can be 4 away from 1, 2, and 3. But again, 1 and 2 is not possible. The 6 can only be 4 away from 1 or 2, so this can never be 6. So this is 7 or 8, which is next to 3 or 4. The 3 or 4 can be 4 away from 7, 8, or 9. The 4 can be only 4 away from 8 or 9. So the 7, 8, or 9 can be 4 away from... for the 7, it has to be 1, 2, or 3, but that's not 4 away from 1. And we can't have a 2, so it would have to be 7, 3, and 4, but that's not allowed, so this can't be 7. And in fact, this has to be 5. Because that's the only way that you can bridge the gap between 9, a high number, and then a low number. Which would be, so therefore this is 9, this is 5, and that's 1. This can be 5 through 9. So if this is a 5, this could be 9. If it's 6 through 9, it could be 1, 2, 3, or 4, or 5. And it cannot be 1, 2, or 3. Therefore, it is 4, 5, or it's 9. Okay. We know there's a 2 here. We know either this is 3 or one of these two is 3. The 3 can be 3 away from 6, 7, or 8. The 6, 7, or 8 can be 3 away. The 6 can be 3 away from a 9. It cannot be 1 or 2 or 4 because of the numbers that we already have. It could be 3. The 7 can be 3 away from 3 specifically because, again, 1, 2, 3, 4. 1, 2, 4 is already taken. The 8 can be 3 away also from 5. So this is 3, 5, or 9. If this is 3, that could be 3 away from 6, 7, or 8. If it's 5, it would have to be 8 specifically because 1, 2, and 9 are already taken care of. If it's 9, it could be 2, 3, and 4. It can't be 2 or 4. It could be 3, though. Or it could be 6. Okay. The rest of row 4 must be 4 through 9 because we have a 1, 2, 1, 2 pair and we have 3 along it. So this is 4 through 9 and this is 4 through 9. Yeah, this just has to be essentially 1 through 8. Because, okay, one thing we know is 9 can never be on this line. So where is the 9 in row 3? It can only be here or here, right? Because it can never be on the Renban line. We know we can't have a 1, so that's, yeah, it's already taken care of. Parity line. Okay. This cannot be 4 because of this 4 here. So this could be 6, 7, 8, and 9. This is also essentially a high number. This is low. These are low. These are all high. This is obviously a low. What can this be? This can only be also 3, 6, 7, or 8. right? Because it sees 1, 2, 4, 5, and 9. So this is 3, 6, 7, or 8. So for both of these, then, if one is 6, 7, and 8, the other one cannot be also 6, 7, and 8, right? Because none of those are 3 away from each other. Therefore, we know the 3 has to be here, which means this cannot be 3. Therefore, this is 5 or 9. If this is 5, this has to be 8 specifically. If this is 9, this has to be 6 specifically. So this can't be 7. If this is 9, it has to be 6 and 6. It could be with 3, though. We know the 3 is here. So the 3 cannot be here along this line. The 3 can't be here along this Renban line. And we know we need a 3 on it because it must connect from 1 through 4. Therefore, the 3 can only be here on the Renban line, which means this can't be 3. This has to be 4. The 4 is only 4 away from an 8, so therefore not the 7, so therefore this is an 8, which means this can't be 8. This can't be 8 anymore, so that forces this to be 6. 6 is only 3 away from a 9, so therefore it can't be 5. The 9 could be next to 3 or 6, so that's fine. And then this could be 3, 6, or 7, so that's fine. 6 cannot be any of these now. So 3 has to be here. What can this be? One of these is 3. This cannot be 3. What's left over? This can't be 9 anymore. So we have 5, 6, and 7 here. And this is 5, 6, or 7. Right? And we know the 5 is one of these two. One of these is 2. One of these is 4. I think we should just assume that this is a normal Renban, because it's so weird to have it be different. Therefore, this is a 4, because the 4 cannot be on this line. Therefore, this must be 2, 7, and 8. Right? This cannot be 8 or 9. Okay, wait, no, this can't be 8. This has to be, it could be a 9. So 8 is one of these two then. I'm not sure which. This has to be 2 with 8, and then 6 or 7. This cannot be 3 and 8, and this can't be 8. Therefore, this must... Okay, we already know there's 8. So this is 5, 6, or 7. This is 3. This can't be 9 because of this 9. Therefore, whereas the 9 here, it has to be here. Whereas the 8, it must be here, which makes that a 2. This must be 3 with 5, 6, or 7 because it cannot contain an 8. One of these is 6 or 7. One of these is 5, 6, or 7. One of these is 5, 6, or 7. This has to be 5, 6, or 7 then. Obviously, neither of these can be 6. So where is the 6 in box 1? It must be one of these two cells. Therefore, that eliminates 6 from the rest of the row, so this can't be 6. Let's see. This can't be 4 because of this 4 now. Where? Actually, we don't know. If this is 5, is this 4 away or 3 away from any digit here? No. 5 is 2 away from 3, 1 away from 6, and 2 away from 7. So this can never be 5, which means this does have to be 7, 8, or 9, which means this cannot be 7. If this were 7, it's obviously not 3 away from 7. It's 1 away from 8, and it's 2 away from 9. So therefore, this can never be 7. Therefore, we know this is a 3, 6, 3, 6 pair. So 3 and 6 cannot be in the rest of box 2. So this can't be 6. We have a 2, 7, 8 triplet. Which means the rest of the Renban cannot contain 2, 7, or 8. So this can't be 7, which makes that a 5, which makes that a 7. This can no longer be 5 or 7. It couldn't anyways because of the way 7 works. It can't be 1, 2, 3, 4, 5, 6, 7, and then another 7 because then that's not really consecutive. So therefore this is 3, this is 6. That means this cannot be 6. So it's a 5, 7, 5, 7 pair in row 1, which means 5 and 7 are eliminated from the rest of the row. So this can't be 7, which means we have a 2, 8, 2, 8 pair in box 2, which eliminates 2 and 8 from the rest of the cells, which makes this a 7. So neither of these two cells can be 7. This is now 8 or 9. And this is 6 or 8. So one of 4 or 5 must be in one of these 3 cells. It cannot be both, because if it were both, the problem is 4 and 5 are not 4 away from each other. So therefore, this has to be a 4 or 5. This can't be 5, though. So if this is not 5, if this is 4, it can be with 8 or 9. If this is 9, it has to be with 5 specifically. So if this is 4, it can be with 8 or 9. If it's 9, it has to be with 5 specifically. Therefore, where is the 7 in row 4? It's only possible here. So this is 7. This is 8 or 9, so that's 3 away from 1 through 6. Obviously, this can't be 4. This has a wide variety. One of these is 8 or 9. What are these digits? It could be 1, 5, 4, or 7. This is 1, 4, 5, or 7. What are these? This can't be 4. So 4 is one of these two cells. This has to be, what? This cannot be 6, so therefore this is 5, which makes that a 7, which makes that a 5. That makes this a 6. So this is even polarity. It cannot be a 4 there. Therefore, and these can't be 5. Therefore, you have a 1, 7, 1, 7 pair in column 2, which means 1 and 7 cannot be in the rest of the column. 5 can't be there, so this must be 4. This is an odd now, which forces this to be even, so this is 2 or 8. This is 2 or 8, which is next to an odd, so this is 1 or 3 because it cannot be 5, 7, or 9. This must be even now, so this is 2, 4, 6, or 8. This is odd. It cannot be 1 or 7. This is 3, 5, or 9. This is even, so it's 6 or 8, and this has to be odd, which means this can't be 8. So therefore, this is 6. This must be odd, which means it must be 1, 3, 7, or 9. So now we have, this has to be 3 and 5 with 1 or 7. This is 1, 2, 7, or 8. Okay. What do the rest of these equal? The rest of this must be 1, 3, and 9. The rest of this must be 2, 6, and 8. This could be 6 or 3. This cannot be 4, 5, or 9. So it could be 1, 2, 3, 6, 7, or 8. And all of them are possible. Okay, what about this? Oh, this can't be 5 because if this, we know one of these three is a 4 or 5 because this can't be 4 or 5. Um. Hmm. Okay. What are the possibilities for this? So can this can never be 5 plus 1 plus 2. It always has to have, okay, so it always has a 7. So this is either, okay, so can this ever be 5, 7, 8? No, because then that would add up to 20, and then you would have two digits trying to add up to 20, which is impossible. So this can never be 8, which means we have a 1, 2, 7 triplet in box 4, which eliminates 1, 2, and 7 from the rest of the box. So therefore, this must be an 8. This can no longer be 8. This can't be 8. Therefore, this adds up to 5 plus 1 plus 7, which is 13, or 5 plus 2 plus 7, which is 14. Well, if it's 14, then this cannot be 6 and 8. It must be 5 and 9 specifically. So it would be 5 and 9 to add up to 14 for these two digits. If it's 13, it cannot be 6 and 7, but it could be 4 and 9. So it could be 4 and 9 or 5 and 8, which would make this 5 and that 8. Okay. Huh. Can the, well, could be. This, okay, so what is not in box 5? It has to have a 5. So one of these two is a 5. This one can't be 5 because of this 5. This can't be 5. Oh, okay. This can't be 5. This can't be 5. This can't be 5 because of the German whisper line. This can't be 5 because of the 3 line. Where's the 5? It has to be here. So this is 5. So this adds up to 8 or it adds up to 9. So this adds up to 8 or it adds up to 9. Either way, you have two digits adding up to at most 9. So 9 can never be on that line. Therefore, where is the 9? It must be here. So this is 9, which means this can't be 9. So this is 4. That makes this 5. The 4 has to be 4 away from an 8. So this is 8. This cannot be 8. This can't be 8, obviously. So, where is the 8 in row 5? It has to be one of these two cells. If this is an 8, that works. If this is not an 8, this has to be an 8, which means it must add up to at most 9, so therefore it'd be 8 and 1, but that would force this to be 2 and 6, which 2 and 6 can never be next to each other on a German whisper line. Therefore, this cannot be 8, so therefore this has to be the 8. So this is 8. This can't be 9 anymore, so this is 3 or 5. What are the possibilities here? 2, 3, 5, and 6 here. This can't be 5. So 2, 3, and 6 here. This is 2, 3, 5, or 6, but it cannot be 2 and 6. We have a 3, 5, 3, 5 pair now in column 6. That eliminates 3 and 5 from the rest of the column. So this can't be 3, this can't be 3 or 5. So this either adds up to 8 or adds up to 9. If it's 8, this would have to be 2 and 6 and 2 and 6 to add up to 8. If it's 9, it could be 2 and 7, which is not allowed, or it'd have to be specifically 3 and 6 then, if that's the case. So either way, the 2 is here. Where's the 4, essentially? The 4 cannot be anywhere else, so it must be here. So this is a 4. This could be 2, 6, 2, 6. If this is 2, 6, that adds up to 8, so this must be 1, 7, which makes that a 2 and that a 1, so that works. If this is 3, 6, that makes this a 1, that's a 2, therefore this is 1 and this is 2, 7, so that works. Okay. This can't be 4 anymore. So it cannot be 4 and 9. So for this to add up, this has to specifically be a 5, which forces this to be 3, which makes that a 5. This can't be 3 or 5. We now have a 1, 7, 1, 7 pair in box 7, which eliminates 1 and 7 from the rest of the cells in the box. So this can't be 1 or 7. This can't be 5, so that makes that a 3, which makes that a 5. Okay. This can no longer be, cannot be 3. This can't be 6. So this is 1, 2, or 3, which is only 3 away from 6 or 7. 3 is, could be, well, any of these could be worked with this, right? This can't be 6, so it must be 2, which means this can't be 2. We cannot have any 2 here, so we have a 1, 3, 1, 3 pair now in column 7, which eliminates 1, 3 from the rest of the column. So therefore this is 9. This can no longer be 9. This is 1 or 3. The last remaining digit in column 7 is a 7. So this is 7. Where is the 7 in row 8? It cannot be any of these, any of the taken cells. This can't be 7 anymore. This can't be 7, and it cannot be here because we have a 7 here. Therefore, this must be a 7 here. Let's see, what else do we have? 6 or 7, 1, 3, 6, 7, or 9. We have a 2 in one of these cells, but we're not sure where. Okay, we have a 2 in one of these cells. Therefore, these can't be 2. None of these can be 2 because of the region sum and then the odd-even parity. So therefore, this can't be 2. One of these is 2. Therefore, this must be the 2, which means this can't be 2. So this is 6, which makes this a 2. And therefore, this cannot be 2. So this is 1, which makes that 2. Therefore, this has to be 1 and 7, adding up to 8. Therefore, this must be 2 and 6, adding up to 8, because we have a 5 in each. Therefore, this is 13. This can't be 1. This must be 3. This adds up to 13. 2, 5, and 6 add up to 13. So this is 5, and this must be 8. Which means this can't be 8, so this is 6, which makes that 8. This 6 means this can't be 6, so this is 7. The 7 can be 3 away from either of these, but this can't be 6 or 7, therefore this is 9. This can't be 3, so that makes that 1, which makes that 3. Which means this can't be 1, so this is 7. That's a 1. The only remaining digit here is 2. And now we're just doing Sudoku. So this is 2, this is 6. This can't be 9, so this is 1, which makes that 3, which makes that 1. This has to be 3, 4, and 9. This can't be 4 or 9, so therefore that's a 3. And these are both 4 or 9. That's 3 in the corner. We celebrate. What's left in row 9 is 1 and 8. This can't be 1, so that makes this an 8, which makes this a 1. Therefore, this can't be 8, so this is 2, which makes that 8. This can't be 6, so this is 3 and 6. What's left here is 2 and 4, but this can't be 2, so this is 4, this is 2. That 4 means that's a 9, which makes that 4, which makes that 9. This is 7 now, and this is a 1. And that's how you solve it. Yay, you solved the puzzle. Yeah, I'm kind of wondering about this Renban rule. If, yeah, you can have consecutive. Maybe it was deliberately put that way. I don't know. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.